Balancing a chemical equation evens out the number of atoms of each type so that they are the same on the reactant and product sides. To balance a chemical reaction, you have to follow very precise rules that we've already seen in this video. Here is an example of balancing an equation with a combustion reaction. In this reaction, butane, C4H10, reacts with oxygen, O2, to give carbon dioxide, CO2, and water, H2O. The atoms involved in this reaction are carbon, hydrogen, and oxygen. To balance the equation, we must first record the number of atoms of each type present on the reactant side and the product side. Let's start with the carbon atoms. On the reactant side, there are 4 carbon atoms in the C4H10 molecule and none in the O2 molecule. On the product side, there is 1 carbon atom in CO2 and none in H2O. To balance the number of carbon atoms in the equation, we need to add a coefficient of 4 in front of the CO2 molecule. There are now 4 carbon atoms on each side of the reaction. For the hydrogen atom, there are 10 in C4H10, but none in O2. On the product side, there are no hydrogen atoms in CO2, and there are 2 in H2O. To balance the number of hydrogen atoms in the equation, we need to multiply the H2O molecule by 5. There are now 10 hydrogen atoms on each side of the equation. Let's finish with oxygen. The balance on the reactant side shows that there are no oxygen atoms in C4H10 and 2 in O2. In the products, there are 8 oxygen atoms because of the CO2 molecule, which has been multiplied by 4. There are 5 oxygen atoms in H2O since we have put a coefficient of 5 in front of the molecule. There are therefore a total of 13 oxygen atoms on the product side and 2 oxygen atoms on the reactant side. In order to have 13 atoms on the reactant side as well, the O2 molecule can be multiplied by 13 over 2, since 13 over 2 times 2 is 13. Now that the coefficients are in place, we have the same number of atoms on each type on the reactant side as on the product side. Are we done yet? Not yet. Look, there's a fraction in the equation, but according to the rules, all coefficients must be whole numbers. To remove the fraction, multiply the whole equation by the denominator of the fraction. In our example, we need to multiply the whole equation by 2. There you go. The chemical equation is balanced and follows all the rules. The secret to becoming a pro at balancing chemical equations is to practice.